In the last lesson, we watched a model quietly get worse as the world drifted. Detecting that is only half the job. Now we respond. A model in production isn't a finished product you ship once, it's a garden you tend. That means retraining, and it means versioning. Here's the problem again. As a curve, a model frozen at week 0 starts near 76% and slides down toward 50 as the data drifts. Do nothing, and this is your future. The fix is to stop freezing the model. Retraining is simple in principle. Fit a fresh model, but on recent data, the last few weeks, instead of the stale week 0 snapshot. The old data taught the old world. Recent data teaches the world as it is now. Out comes a new model. Call it version 2. Watch what that does. The faint red line is the frozen model, still rotting. The green line is what you actually get if you retrain on a schedule. Every time we retrain, accuracy jumps back up, then drifts, then we retrain again, a sawtooth. Instead of collapsing to 50, it holds in the mid-60s, about 15 points recovered, just by keeping the model fresh. But here's a trap. A freshly trained model is not automatically better. A bad data pull, an overfit, a subtle leak, any of these can make version 2 worse than what you already have. You must never just swap it into production on faith. You have to prove it's better first. The way you prove it is a shadow test. You run the new candidate right alongside the current model, on the very same live traffic, and compare. On this week's data, the incumbent scores 66%, the candidate, 78%. Same data, a fair fight, and the candidate wins by 12 points. It won the fair fight, so now we promote it. Version 2 becomes the live model. And notice one small, crucial thing. We don't delete version 1. We keep it. You'll see why in just a moment. Here's why. Imagine a candidate trained on a glitched week, a broken pipeline sent income in cents instead of dollars. In the shadow test, it scores 47% against the incumbent's 56%. Worse, so we reject it, and it never touches real users. And because version 1 was kept, rolling back is instant. Versioning is what makes bad releases survivable. So you keep a registry, every model version, tagged and stored, when it was trained, on what data, and how it scored. Version 1 at week 0, version 2 at week 4, and so on, with the live one clearly marked. Remember that every API response carried a model version? This is why, so you always know exactly which model made any given decision. How often should you retrain? 2 common answers. On a schedule, say every week, which is simple and predictable. Or on a trigger, you retrain the moment the drift alarm from last lesson fires. It's a trade-off. Retrain too often and you burn compute and risk needless churn. Too rarely, and accuracy rots between runs. Put every piece together and you get a loop that runs itself. Monitor the live model. Detect drift. Retrain on fresh data. Shadow test the candidate. Promote it if it wins, or roll back if it doesn't. Then monitor again. Around and around. That cycle is what keeps a model healthy in production, indefinitely. To recap, a live model must be retrained as the world drifts. Retraining on recent data recovers the accuracy you were losing. Always shadow test a candidate against the current model before promoting it. And version everything, so a bad model can be rolled back in seconds. And that completes Module 9. You've taken a model far beyond the notebook, through imbalance, calibration, interpretability, fairness, and privacy, then packaging, batch versus real-time serving, and a prediction API, and finally monitoring for drift, retraining, and versioning. Your model is ready for the real world. Next, you'll put all of it together in the capstone, one project, from problem to deployment, end to end.